Hi everyone, my name is Louise Kapaner and today I'll be leading the Computational Social Science Introductory Workshop. Okay, so throughout this workshop we're going to be covering three main sections, which include the first one is what is up with computational social science? So what does this even mean? Then we're going to discuss a bit about how you actually become a computational social scientist. And finally, we'll cover the 8 steps of CSS, which is where we'll have the most interactive part of the workshop and where you can really get stuck in sketching out your own CSS project. And of course, at the end, there'll be time for final thoughts and any questions that you might have. What is computational social science? It's the use of computational and empirical methods to address social science questions. So we can break this down a little bit more. So computational social science requires human thinking to identify important research questions. And because we're going to be dealing with social science questions, we need to understand how people behave and what they want to achieve. So we need that social science brain in order to formulate those really interesting research questions. As you can see, we also need a little sprinkle of computer thinking, and that's so that we can turn these research questions into computational or empirical methods. And after you've completed your research, you're going to need that social science human thinking again to effectively communicate those results to other people. So another way to understand computational social science is to think about what its main components are. So let's just go through a few points. So computational social science is not just using computers within a social science research project. I'm sure you've all sent an email, but that doesn't necessarily mean that you're doing computational social science. It's also not just using digital versions of purely traditional social science methods. So it's not just asking for survey participants to complete an online form instead of handing one out. So it's not just a digital version of something that you would normally do in social science. And it's not just using digital, but purely non-empirical methods. So I'll go ahead and I'm going to give you a few examples that will kind of untangle these ideas a bit more, because I know they're not always entirely obvious. So here's some examples that might help put this into context a bit. So one example of a CSS project would be collecting, processing, and analyzing millions of online news articles to show changing political attitudes. So you can see how we have that human thinking here to formulate our social science research question about political attitudes. But we also have that computer thinking inherent in using a computational method. So in this case, it would be web scraping, and that's what we use to gather a massive amount of news articles. We could also use real-time weather and traffic data to show how travelers react to events. So for example, maybe you hear that there's a storm that has caused damage to a local town, and you want to look at how people react and how that event is dealt with in real time. So you can see how this project isn't just a case of using a computer with a social science project or using a digital version of traditional social science methods. Instead, we have these uniquely computational methods. And we have some other examples, which include combining data from novel wearables or apps to establish a correlation between social media activity and heart rate. So that could be aiming to answer a social science question about how people feel about certain images. So you could look at how they react, are there positive or negative feelings, are they irritated, and so on. Finally, we could also be interested in mapping family names over time by importing, processing, and formatting centuries of parish records. That could allow you to explore the movement of certain families to different areas, or you could maybe look at the changes in family size or whether families have moved away or not. So these are just a few kinds of broad but really CSS examples. Moving on, there are key factors that make a CSS project computational. And the first one of these is data volume, complexity, speed, difficulty, or novelty. And this is more important than the exact data source or type. So in our previous example where we had parish records, the source of data is not entirely important. It's about the volume and the complexity and, that difficulty or the novelty, that data. Additionally, another key factor, like I've said, is that the data must pertain to people, actions, behaviors, choices, and statements. That's that key social science ingredient that we'll need. And just to hone in on that point, the research question should be a social science research question, which uses that atypical data to talk about how people make decisions or what influences their behavior and choices. So the exact research question is not important, but it must be a social science question. And that's where we have this really obvious intersection between the computation and the social science. And that's what we're going to focus on today. And here we have a really important quote. So in essence, CSS is an opportunity to do socially valuable research that would not be possible without computational methods and tools. So by this, I mean that we couldn't, for example, manually scan years of police recorded statistics to try and understand how crime rates have changed over the last 10 years. This physically wouldn't be possible to do manually, but with the use of computers, we can apply advanced statistics and models in order to understand that change in crime rates. We could look at how we could count many types of crimes that have taken place in certain areas, and then we could aggregate these crimes to map them spatially. We could look at exploring the long-term trend seasonality or the noise components of these different crime types. And this type of research just wouldn't be possible without the use of those computational methods. Another example could be, as I mentioned before, web scraping millions of online articles. And you could be doing that to try and understand how political opinions have changed over 20 years. In order to get a sense of political opinions, we'd want to also examine, the words in the articles and how many words belong to different categories and what sort of themes appear. And we could look at the proportions of these words and how that changes over time. So that's something that we wouldn't be able to do without computational methods like web scraping and natural language processing. So in order to sort of see if any of that made sense, we're going to have a little bit more interaction now. And I'm going to give you guys the chance to vote on whether you think a given project is a computational social science project or not. So if you want to head back over to Mentimeter, we can get this set up and then you can start voting. So I'm just going to switch to Mentimeter now. So if you guys want to head over there, maybe Emma or Nadia could pop the code back in the chat for anyone who's joined late. If you head over to menti.com. All right. So yeah, it seems like already got people voting, but is this CSS or not? So the example is scanning historical recipes and using AI algorithms to recognize text to identify that should be ingredients, and measures used over time. That should say to identify ingredients, then measures used over time. So we've got a lot of votes coming in. Seems like the majority have said that this is definitely CSS. And we have some saying there's not enough social science, very small amount saying there's not enough computation. So in my opinion, I'd say that this project does sound quite computational because we're talking about the use of AI algorithms to scan recipes. So we definitely have those computational methods being used here. But I suppose the 27% are saying there's not enough social science. I could see how you come to that conclusion because, this one sentence here doesn't seem to indicate that we're asking any questions about people's behaviors and choices. So me personally, I'd probably say that this is CSS, but I do agree with people that are saying it's not because we don't really have enough information. And it's not clear exactly what the social science question is here. But, maybe we could be talking about how imported foreign foods integrate into domestic scenes and how people then take that up. Maybe it could relate to how wealthy people then start adopting, fancy foreign foods into their diet. It could be exploring how that then trickles down and, sort of like foreign foods and ingredients then become more normalized. So you could see how that would be a social science question. But it also could just be looking to talk about the proportions of natural foods that people are eating over time. And maybe that would be more of a biology question. So yeah, it's kind of one of those annoying ones where there's not really a right or wrong answer, but this is just to help us, explore different methods in CSS. But me personally, I'd probably say it does look CSS to me. So let's move on to the next example. So is this CSS or not? Using gamified smart home displays to understand how people interact with energy-saving technologies. What do we reckon? All right, I'll just let some votes flow in. We've got some people saying they need more information to decide. Absolutely fair enough. Again, looks like definitely CSS has it in this one. So we have some people saying there's not enough computation. Personally, I'd say that there probably is. You've got this gamified smart home display, that's going to capture a lot of digital data, and it's looking at how people interact with it. So it might be tracking, what time of day it is that they interact with it, maybe who in the family is interacting with it. So it's possibly got some sort of tracking data, and that would, in my opinion, make it fall under CSS. Maybe the purpose of it as well is going to look at changing people's behavior to make them engage more with energy-saving technologies. That would definitely pose some sort of social science question. So yeah, in this one, I probably agree. It looks like it's CSS. We've got that looking at how people interact with them. I can also see how people come to other conclusions with that one. So let's move on. Is this CSS or not? We're looking at advertising for survey participation on social media. And once we get those responses, we're going to store them in a database. Is this CSS or not? So you could think as well back to that slide where we talked about what CSS is not. So it's not just, and then I had a few points of, what makes something CSS or not. So let's see what, here's I need to actually open voting on this. That's my bad. Okay. So it seems we've got the majority saying that there's not enough computation here. So yeah, I would also agree with that. So like I said, if you remember on the previous slide, we talked about how CSS, it's not just using digitized versions of traditional survey methods. There is no clear line between, how much computation is enough computation, but you have to ask yourself, if you can do your research without digital tools, then it's probably not CSS. If you draw the conversation back to surveys in itself, typically the larger the survey sample, the more necessity there will be for computational tools, because the analysis is going to become much harder. But the use of online surveys doesn't automatically make it a CSS project, because you could probably collect roughly the same amount of responses through paper surveys as you would online. Might take you a bit longer, but you'd be able to do that, right? And yeah, we've got some people saying that they need more information to decide, and that's fair because, like I said, these are just one sentence, right? One sentence. We don't really know where this project is going to go from here, so perhaps it'll branch out into something more computational. But yeah, let's move on to the next one. So is this CSS or not? Reading in real-time weather and air pollution data to create complex models of hyperlocal air quality. What do we think? It looks like the majority have agreed that this is not CSS due to a lack of a social science focus. So we'd have to think about, is there a link between hyperlocal air quality and human behavior? From this statement, it doesn't look like there's any social science sort of question going on here. We'd have to know more about the project. Are we looking for a political impact, or is there going to be maybe a overlap or branching out into different sort of fields and schools? So maybe this is going to branch into geoscience or physics. So it's not clear from that statement that there's any, intent to go down the social science route. So I think with this, I would have to agree with the majority that there's not enough social science in it. And finally, we've got our last poll, which is, we're training a neural network on social media data to create a believable chatbot that counteracts online radicalization. So straight out of the gate, we've got a few people saying definitely CSS. Some people are saying there's not enough social science. We need more information to decide. I'll just let that go for another few seconds. So personally, I'd have to agree with the majority here. it seems to include all of the components of a CSS project. There seems to be an implicit social science research question as we're focusing on people's actions and attitudes and behaviors. And we have that computational method, which is going to help us explore this. So we've got a neural network, which has been trained on social media data. For those of you that don't know what a neural network is, these are kind of artificial intelligence that teaches computers to process data in a way that's inspired by the human brain. So it's a type of machine learning process, also called deep learning, that uses interconnected nodes or neurons in a layered structure that resembles the human brain. So basically what we can do is predict the user's behavior based on their posts and their chats from their social media accounts. So there's also, going to be a bit of web scraping involved, all around very computational stuff. The chatbot's probably going to have some natural language processing in it too. So in my opinion, I'd say definitely CSS. So that was our last example, and thanks to everyone for taking part. It's really interesting seeing what you guys think as well. I'm going to just go ahead and switch the screen back now. Actually, no, I'm not. We're going to have a little word cloud as well. So you can send in, 3 terms that tell us what you've learned about CSS. So maybe something that you found interesting, something that surprised you, or, anything you want to send in. Big data sets, yep. So you think about scraping like, millions of online articles, you can have a massive data set, right? And we talked about, the fact that we're working with like big data, high dimensional data, social movement, yeah. So we've got that social science component, socially valuable. Yep, social scientists have got to think about, often have to justify their research on the grounds it's going to, be valuable for society. Human behavior, expectations, transdisciplinarity, yeah, for sure. Working with different fields. Exciting, yeah, I'd say so. New data, analyzing behavior. But yeah, it seems like we've got a lot of people saying big data, complexity, coding, yep. And I'll give this a few more seconds, see if it changes that much. Can be difficult to define, yeah, for sure, yeah. Neural network, valuable knowledge, theory matters, for sure. Programming, social science genre, yeah. This is all really interesting, guys. Vague space to research, yeah. We're going to try and break it down a bit more after we've had a little break. All right, I'm going to stop that now and go back to the presentation. Thanks for that, guys. Hopefully everyone can see, and we're back to the PowerPoint. I'm going to give you guys a little 5-minute break. Grab a brew and go for a walk. Not too long a walk, but get a drink of water, whatever you need to do. And we'll meet back here in 5 minutes. So let's see what time we're on. Okay. So we're going to talk a bit about how to become a computational social scientist now. And first, we're going to start by covering what a social scientist is. So the first thing that we can say is that social scientists think like people. And what I mean by this is that they use a lot of those human type thinking skills like abstraction, inference. They're going to really understand fuzzy sort of concepts and background knowledge. And social scientists in general don't shy away from grey areas or overlapping categories. These are just part and parcel of being a social scientist. And it's no surprise that they're going to need those human type thinking skills because they're studying people, interactions, and behaviors, and that's going to require a certain skill set. But it is also important to note that social scientists build up a lot of data skills in the course of doing their research. So if you think about things like response categorization and coding, quality evaluation, pattern detections, and statistics, these are all things that social scientists regularly do. But whilst they will be using computers and statistical programs, this often doesn't involve writing computer code. You might be doing some analysis on SPSS or Stata, but yeah, like I said, maybe not so much any programming or code. And then we have computer scientists. And we're making some big generalizations here, but in contrast to that, sort of human type thinking skills that social scientists have, We can say that computer scientists think more like computers. So what I mean by that is that the thinking skills that they have are more along the lines of concrete definitions and absolutes. They think in terms of strict hierarchies and categories, and clearly defined and scoped variables and rules. And in terms of data skills, computer scientists collect, analyze, and manipulate data through programming scripts, computational methods, and technological tools. But unlike social scientists, they might not be as familiar with identifying or motivating research projects on the basis of societal impact or value. So those of you watching that are social scientists, you might have had to justify your research on the grounds that will make the world a better place. So, this could be, well, I'm researching radicalization in order to produce insights that could lead to countermeasures. Whereas a computer scientist, they might be more focused on a sort of logical justification for a particular project. And that could be, I want this algorithm to be more efficient so that it uses less memory. So we can kind of see the differences here. And obviously, this is very broad. So in order to undertake a computational social science project, you're going to need a blend of those social science and computer science skills. You'll need that sort of human thinking that I've mentioned, the ability to understand gray areas, fuzzy concepts, abstraction, inference. You're going to need that computer thinking. So you're going to want to be able to translate that research question into a computational method. So you might have to have that more, programming sort of mindset, more of a logical justification for why you're doing things. You're going to need open-mindedness as well. We'll talk a bit more about that. And you'll need a mixed problem to tackle. So let's have a look at each of these 4 things in a bit more detail. So yeah, you'll need those skills that we briefly touched on before. And those are things like being able to identify important problems or knowledge gaps. You're going to want to be able to consider possible solutions. And you'll need to be able to connect problems to relevant theories or perspectives. And you want to be able to collect relevant information and research to frame your approach. And these are all things that social scientists really excel at. The ability to understand context and nuanced perspectives, and how to communicate abstract ideas, and how to attack a research question. And that's not to say that computer scientists can't do this or that they're robots. I'm just talking in broad generalizations here about the differences between the two fields. Whereas computer scientists might find this a bit more difficult. They might be more used to those concrete definitions and absolutes rather than, these sort of gray areas or murky social science concepts. So that human thinking is going to be the first thing that you need. And now we're going to cover why you also need these computer thinking skills. So what do you need? You'll need the ability to access, organize, process, and handle vast or complex data. You're going to want to learn how to write collaborative code, and also how to properly document your workflow, which is often a step that a lot of people do neglect. These are going to be skills that computer scientists might find quite easy, as well as data scientists who've been trained in computational methods. But for social scientists, it can be much harder to transition towards these computer thinking skills. But like I said in a few slides ago, social scientists do have those data skills that they can build upon. And these are things that I've mentioned before, like coding responses, pattern detection and statistics, formatting your surveys. And this is a really important ingredient. I can tell you, as someone that has moved away from a social science field to doing more CSS type stuff, it can seem pretty intimidating at first. You might just have that perception of, oh, I don't have a coding brain, and that's why it's good to remember that no one's going to start out with all of the skills that they need, nor are you going to know all of the skills that you might need to acquire. And that happens quite a lot. You might start off by saying, I want to scrape tweets for information on the 2016 US election. And you're going to expect, all right, well, I'll need some coding ability, right? But you might not know that that's going to entail learning about an API or different file formats or ways that you're going to visualize the data. But if you approach CSS with an open mind and a willingness to learn, you're going to be able to gain those skills along the way. And you'll also start to understand that some skills will have a steeper learning curve than others. So It might be fairly simple to learn how to do a little bit of web scraping maybe, but learning to build your own neural network and then train it on a large amount of data, that's going to be, much more complex. And another really important thing to note is that you can't do it all by yourself. You're going to need to be prepared to collaborate. So you can look at collaborating with people from other fields, and that's where you start to get this bridge between the social science and computing worlds. As social scientists learn more about computing and vice versa, we begin to see more conversation and collaboration between these two fields, and that produces really exciting and interesting research. And what you'll find is that you don't need to know everything about computer science. What you want to know is enough to have those productive collaborative conversations with others in the field. Finally, what you're going to need is a problem that requires these CSS skills, and that's a mixed problem. So one that requires that blend of human thinking and computer thinking. And some of you might be here because you've already encountered one of those problems, and that won't surprise me because as resources become more digitized, these problems are going to become more relevant. We've got the fact that large volumes of data are being made available and updated faster than ever. So if we think about maybe a classic social science problem, maybe we're interested in how men and women move through cities differently. Or maybe we want to narrow down that question to look at how people with disabilities navigate cities. Traditionally, for this kind of social science problem, you might station some interviewers in different places to stop people as they go past, right? Or you might want to count how many people go by that are maybe using mobility aids. Or maybe you're going to send out some surveys to some people's houses. But now there's much more opportunity for us to gather that large amount of data with these novel computational methods. So you could collect data from public transport networks about how many people bought tickets or how many people swiped their card at the tram stop. You can even get sensors which can track how many cars go past a given point. You could use AI algorithms and CCTV cameras to identify how many people are moving through a space and at what speed. So as you can see, there are all these new ways of approaching traditional social science questions, but there's also no reason why you have to abandon those traditional methods completely, right? So part of good research is going to be evaluating different methods and then comparing outcomes. And it might be interesting to see whether by using those different methods, you can then get different answers. And then if you do get different answers, then you can ask, well, why is that? Which then may prompt further questions and so on. So there is a massive amount of benefit with building upon, building up some computational skills and then strengthening those social science skills that you might already have. So what I want to do here is quickly introduce an 8-step process for how to undertake your CSS project. So these steps are going to include, first, identifying the problem, exploring the problems, formalizing your concept, collecting data, implementing the software, and then verifying those concepts. And then using those concepts to experiment or analyze the data, discussing your findings, presenting a conclusion, then communicating, publishing, and presenting, as well as sharing your findings and documenting and validating your findings. To make this process more useful to you, I want you to start thinking about either a project that you want to tackle or a research idea that you've been thinking about, or it can even be a project that you've done in the past. You can jot this idea down or maybe even put it in the chat and just have it in mind as we go through these steps. So once you've identified the problem, you're going to want to be as clear and specific as possible about the pattern, the problem, or the lack of insight that you're going to be covering, right? You're going to want to identify who is involved, where it is, etc. And that's going to help you to define your research initiative. So maybe you have a goal in mind. Let's say we want to get more people traveling actively through the city centres. We want less cars on the road, and we want more people riding their bikes or, scooters or whatever, or just being able to get from A to B in their wheelchair. So the research question might be, what are the barriers to active travel in city centres? And what you need to do then is identify who is involved. So you can start to list who is involved, whether that be companies, people, or different demographics that might be of interest to you. So maybe you'd want to look at city councils, bus companies, different businesses, vehicles. And it's better to just go all out with these lists as well. And that's going to give you different avenues to explore. And you can always just, go back and cross out any that you've done a bit more investigation into and decided that they're not actually relevant. So that's going to be how you can really hone in on this first step. And the next step is going to be, it's going to involve exploring the problem. And this is where you'll gather information and perspectives in multiple ways. So you might do some preliminary sort of surveys, observations, secondary data analysis, web scraping, accessing APIs. So this might also, it might involve conducting a few interviews with people of interest. You could interview, if we go with our example from before, maybe we'll interview the manager for the city's transport network or some local council workers. But you would also probably need a survey or observations or secondary data analysis to capture how many people are actually moving through the city centre. So it's about using those different methods and tools to further enhance your understanding of the problem or research topic. You'll also want to spell out sub-problems, processes, relationships, simplifications, assumptions, etc. So after settling on your main research question, you're going to need to get more specific in order to make that question relevant and measurable. So if what are the barriers to active travel in the city centre is your main question, you might specifically be focusing on what are the barriers to active travel through this specific city centre at this specific time of day, given the way that these specific roads are laid out, right? So that's where this is the step where you really nail down the particulars of your research question. Moving on to step 3, you'll need to formalise your concepts. And what I mean by this is you'll want to make all the concepts and processes explicit, formal, and both computer and human understandable. So oftentimes we use something known as pseudocode, but you don't need to know how to write code. What you do need to know is just start understanding how to formalise things when it comes to transitioning from that research question to then using those computational methods. So maybe you have a research question which focuses on trust. Trust is a very social sciencey sort of concept. And if your goal is to get a computer to be able to measure it or model it or represent it in, a simulation, you're going to have to define it in a way that a computer would understand. So maybe you will define trust as a variable between 0 and 100. Then you're going to need to make rules about how that variable will change in certain situations. So maybe if you're looking at the way two parties interact, maybe if they interact positively, that trust increases. And then given a negative interaction where one of the parties is judged to be deceitful, maybe that level of trust then declines or resets to 0. So you have to start thinking about how to formalize concepts in your research question so that a computer would be able to understand it. And then we're on to step 4. So actually what I'm going to do now, because I should have done it a few steps earlier, is just get some idea of what you guys are thinking about and what you're jotting down. So what I'm going to do now is if you could head over to Mentimeter. Sorry, I should have done this a few slides earlier. I'm just going to get a bit of idea about what are your first and your second steps. So what kind of ideas are you thinking about? So I'll just stop sharing for now and we'll head back over to Mentimeter. So hopefully you guys can see this. Yeah, I do apologize, should have done this a bit earlier, but just maybe tell me a bit about your step 1 and 2. So what research questions are you thinking about? How would you think about exploring that problem? Hopefully you guys will be able to type in anything that you want to. Tell us a bit about what your ideas are, what you'd research. So we've got a few answers coming in. All right, sweet. So we've got 7 answers. I will find out how I can actually access them. Someone's also just said, can we have access to the recording of the session because they've joined late? Yep, this will all be up on YouTube after, so no worries. Try clicking view results. Is my banner maybe hiding it at the top? Maybe it's because I'm sharing my screen. I can't see that. Unfortunately, I can't share it in full screen mode. I'm really sorry about this. I guess it just goes to show that I'm not computational enough to be using Mentimeter, but let's have a look at what some of you guys have put. Hopefully you guys can see this. I will just read it out if you can't. We've got identify the problem and who it is that's involved in it. Yep, nice one. Nothing specific at present, but your step methodology is really useful. Oh, nice one. Glad that you think so. Defining terms so they are mutually exclusive, assigning weights or numbering the terms. Yeah, definitely important. You want to translate that social science into something that your computer can be able to understand. We've got someone that's looking at perception difference between different refugee and immigrant groups. That sounds really interesting. Be a good one for maybe some potential web scraping as well. PhD study offer gaps. Beginning to think it's not something that would work as a CSS project. I don't know, maybe talk to me about it at the end. I'd like to hear more about that. Looking at the change in attitudes over time about non-English speaking immigrants. Again, that would be a really good one to explore with some web scraping. You could scrape some tweets, although, you know, it's an interesting one, right? Because when you scrape Twitter, you've got to think, well, you're not getting, that demographic is largely male. It's going to be quite young as well. So there are pros and cons to using these different methods. Analyze attitudes on immigration from social media. Yeah, sweet. So we've got like quite a bit on that. How gender is presented in magazines, word scraping to find themes and most common words. Yeah, that'd be a really cool one. You could use a lot of natural language processing for that. That'd be super, super interesting. We've got one that's slightly cut off. Implementing intervention to increase sense of belonging of, and then unfortunately for me, it's a little bit cut off. Really screwed up with these with this slide. Someone said these 8 steps are excellent. I'm a data librarian in Italy, so assisting PhDs with their research design and data strategies. Thank you. Oh, thanks. That sounds super interesting and no worries at all. Glad you found it useful. So yeah, we've got some really, really interesting research avenues here, and it seems like you guys are really getting to grips with kind of like how you formulate a CSS project. I'm going to see, hopefully, when I go back to this, I can see the full responses. I am sorry about this, guys. I had to change the questions to a different format last minute, but I'll keep this in mind for next time. This is not the best way to do it. So I'm going to switch back now to the presentation and we'll continue through those 8 steps. So we're now on to step 4. And what this involves is collecting data, implementing software and verifying your process. So you'll need to select and implement one or more methods. Many of you might have thought about these methods in your step 2. So some of you decided you want to do social media analysis, you want to do some web scraping. So yeah, you could pick any sort of method. Maybe you're looking at agent-based modeling or sentiment analysis. So this is a step where you implement these methods and make sure that they work in the way that you anticipated. So maybe the data comes in a different format than you might have expected, or maybe you're just getting a bunch of error messages in your code. So we're looking at, does it work in the way that we expect it to? Maybe if it doesn't, you could use a toy data set. So that's a smaller data set with less variables, rather than your full data set while you fine tune your method. That's something I often end up doing. I have a massive data set and I think I'm going to make it smaller because it's just so much easier to work with and see if your sort of computation and your any match that you're doing is actually correct. And of course, the choice of method is going to be highly dependent on the research topic. And what you're going to need to do as well is thoroughly check that the selected method has been implemented correctly. And that's what we mean when we talk about verifying your process or method. It's about answering the question, did we do the right thing? Oh, sorry, did we do the thing right? Important distinction there. And at step 5, you're going to then want to experiment and analyze the data. So you will, of course, run the experiments, build any models that you need, analyze the data, or otherwise use the method selected in the previous step. And you'll need to identify and explain the results within the context of the experiments and the model or the method that you're using. Then, once you've run your experiments and you've analysed the data, you can then start to interrogate the results and form some conclusions. So this means going beyond the experiment and the model or the method that you've used to draw some conclusions about what the results mean. So what sort of picture they're forming. Does it support any policy recommendations? So is the research indicating that there might be policy recommendation? Who or what do these results affect, and why does it matter? And what should change? So who benefits from that proposed change? So if we use that example of looking at how people move through cities, perhaps you found that people with disabilities related to mobility have more difficulty navigating through particular areas. Maybe there's uneven surfaces or particular roads that are too narrow, in which case you can then recommend some changes, wider footpaths in XYZ area, right? So we're nearing the end of the research process now, where we're going to focus on communicating and sharing that research. And in terms of communicating the research, it's important to understand that, all of the previous steps must be communicated to multiple audiences in multiple ways. And what's really important is that you think about short-term and long-term engagement. For a lot of us, our mind will instantly go to, well, I want to get this published in an academic journal, which obviously for sure, definitely important, but it's also good to think about other forms of communication. So are you going to present your work at a particular conference or submit a piece about it to a blog? And you can think about whether there's any workshops or classes that you could present on it to get your research shared more widely. And with that, you'll want to think about how you adapt your style and your tone of communication to suit those different audiences, right? Presenting at a conference, for example, is going to be a much different style and tone than submitting a piece for a blog. So you're going to really want to think about how you communicate that research to different audiences. And finally, you're going to want to share, document, and validate your findings. And what we mean when we talk about validating your research is making sure that the right thing was done by allowing your work to be studied, reproduced, and/or modified as needed. And to do that, you want to allow as many people as possible to be able to access your methodology and any code or data. You're going to want your research to be as transparent, well-documented, and open as possible. And of course, there are going to be caveats to this. So you might be working with admin data that's restricted. So you could look at workarounds. Maybe you could create a dummy data set so that people can still run your code and work through your methodology. And then just a note on that reproducibility is a really important area of research, and it's often neglected, which is why it's good to think about how you'll document your work before your research gets underway. And there's just a few things to note as we head towards the end of the presentation. And that's that these steps that I've outlined, these 8 steps, they're not linear. There's many points from each step that you'll need to return to or apply throughout the research process. For instance, documenting your research is something that you'll want to apply from the beginning. And when it comes to computational social science projects, most or all of them are going to require many iterations. And that means you're going to need to revisit certain steps. So maybe you'll come up with a research question in step 1, but after you've actually explored that problem further in step 2, you might want to jump back to step 1 to then reformulate that research question in light of something that you've read. Or maybe you're on step 4 and you've implemented your method, but you need to then go back to step 3 because you've not outlined the concepts and the processes enough. So this is iterative. And that's why documentation is really important, so that you can capture all of those nuances and changes as your research evolves. And I've often had it where I'll make some really important changes to my code, but I don't end up documenting it. And then when I come to writing up my methodology, I'm struggling to explain why I opted for this type of algorithm or this particular Python package. And yeah, it's a shame because those are the really interesting insights, right? It helps you figure out how someone took a path and why they took that particular path. So it is really important to just document each of your steps. And it just makes the writing process so much easier, right? You have everything there that you need. So before we head to the end, I'm just going to go back to Mentimeter because we've got a few more polls and stuff. But just to note, this is pretty much the end of the presentation. We are going to have some Q&A, but I'll just head to Mentimeter because we're going to do a few last interactions. So I just want to know some main takeaway points that you have. So anything that you've learned that's interesting today, what maybe just a few points on what you think of CSS, yeah, anything you feel like nice, fascinating, useful, 8 steps, less intimidating now. That's great to hear, truly. Yeah, that's exactly what we want to hear because, you know, just because you're a social scientist does not mean that you can't use computational methods, for sure. Useful, accessible layout, nice, I'm glad, yeah. Dive in, refine, already have some skills, yeah, nice one. You're all going to have those. If you're a social scientist, you have like you know how to sort of you've had to recode questions, you've had to do statistical analysis, right? Like you have that good data foundation. Reproducibility, nice, simpler than I thought, love to hear that. Diverse skills needed, definitely. And if anyone is interested, we've got a bunch of really good past webinars on CSS stuff like text mining, machine learning, and maybe Nadia could also link the GitHub as well. So we've got these things on the GitHub called binders, and they allow you to code without setting up your computer environment. So it is really good if you want to get stuck in with some text mining or I'm trying to think what other stuff we have on there. We have a bunch of stuff, but just it's not coming to mind right now. You know, you want to look at synthetic data, whatever, you can do that through our binder notebooks without having to have any previous coding knowledge. So Nadia will link that in the chat if you want to access that. But yeah, let's have a look at some more of these. Clarity on overlap, fair enough. Promising, more effective, human technical balance, yeah, for sure. I mean, I'm sure a lot of you have heard of ChatGPT and just like the strides that we've made in AI in like the past month. So it's a cool field to be getting interested in, you know, using some of those techniques. Nice. I'm also going to ask you, okay, just a few references as well for anyone that's interested. Just to say as well, we are going to be making these presentation slides available, so you can always go back and look at these in more detail. It's all going to be uploaded online as well, so you're going to have the recording. Anything you need to go back and check, you can do. So I'll also leave up as well. I'll leave up my contact details as well. So I've got a Twitter account and you've got my email there. If you want to ask me anything personal about the not anything personal, anything about the workshop, anything CSS, get in touch. Let me know what you're interested in researching. Let me know if you're undertaking a project. And like I said, we flag those CSS drop-ins as well, and they're really useful if you just want to like connect with other people in different fields that are doing CSS stuff. They're really useful.